if you have a polynomial divided by a polynomial, that's what makes it a rational function. 3.5 is all rational functions or the fraction functions. And so we have a lot of rules that go along with this to help us find the guidelines, because we will have breaks in our graph from having this denominator issue. But first thing you want to do is make sure you reduce your equation first. If you can reduce this expression, do so. That doesn't happen in too many of your homework problems, I'll tell you, so don't stress yourself trying to get it to factor. Look at it and it may factor, but not very many do. But this one does. Notice we could factor that numerator, and then the x minus 2's are a matching set, so you can reduce that, and now it's just f of x equals x plus 2. And what type of function, or what does this graph to look like? Y equals x plus 2. Just a line. So it reduced to just a line, and if we graph this line, we would know that this is a y-intercept at 2, rise 1, run 1. It graphs to look like that line. Except you can't have the whole line filled in, because the original equation, if x equals 2, if we were doing a t-table and plugged in 2, it would make that undefined. So here's what we do. At x is positive 2, we make a little hole in the graph, and we omit that specific point as a solution. Because remember, graphing is a picture of all the xy points that solves the equation. So if I have 2, 4 as a solution, it doesn't actually solve the original equation. All right, in its reduced form it does, but we always have to go back to the original that it has to work there too. All right, so that's what you'll do, like a little hole in the graph if it reduces. Okay, now moving on. This would be on the couple pages over. It says graph the function with a 6, 5. I want to go through all of your steps for graphing a rational function with this one. You can see there's a narrative page beside it with all the steps listed, the 6-step process. And I've got some of those up here. The first step is look for any vertical asymptotes. And that's always found where the denominator equals 0. So we'll set this denominator, x squared plus 5, equal to 0. Now it's quadratic, so you're looking for maybe 2 solutions, but actually, when you throw the 5 across the line and square root both sides, they're imaginary solutions. So we don't see any real answers for that, so there are no vertical asymptotes in this graph. All right, but it's good to know. We got to rule out all possibilities, so we had to look for any vertical breaks in the graph. I mean, since it's multiple choice, you can kind of look at the choices now and tell there's 3 that have no vertical breaks in the graph. Well, the last one might as well. But probably the second one and the third one, B and C, are smooth all the way across. No breaks from left to right. Okay, so we've ruled that out. Now go to the second step, which is find any horizontal or oblique asymptote. This next part, these are all mutually exclusive situations because they have to do with the degree. The first situation is if the numerator has a lower degree than the denominator, y is 0. The second situation is if they have the same degree, then it's the numbers in the lead divided. And then the third situation with the degree is if the top is 1 more than the bottom. So again, these are all 3 mutually exclusive events. You can't be this and this or this and this at the same time, okay? So it would just be one of those or none. But we have to look at the degree of our polynomial, and sometimes you'll have to think about how that would multiply out. So if you FOILed the top, you'd get x squared minus 3x, 1x, and minus 3. But all we're interested in is that biggest exponent. That's our degree. So it'd be 1x squared, and then this is already in form, x squared plus 5. But anyway, the degree of the top is 2, the degree of the bottom is 2. That's this situation. When the degree is the same, we divide the numbers in the lead. So 1 over 1, or y equals 1. There's a horizontal asymptote at y equals 1. So I dot that line in to show that guideline. All right, step 3, find the y-intercepts. Y-intercepts are found by letting x equal 0. So back to the original problem, if I let x be 0, I'll have 0 plus 1, 0 minus 3 over 0 squared plus 5. Simplify all that together, and you have negative 3/5. The y-intercept should be at negative 3/5. I'll just kind of estimate about a half there. And you'll check my arithmetic. I make mistakes. I get in a hurry. But that should be 1 times negative 3, 0 squared and 5 is 5. Okay, next step. Step 4. Find any x-intercepts. X-intercepts are found by letting y equal 0. So, from what we said earlier, can you kind of just look at it and tell the y-intercepts are negative 1 and 3? The process was we let y equal 0, set all this equal to 0, and then cross multiply. When you put 0 over 1, again because that's the y value, y is 0, equal to your equation, you can cross multiply. 0 times the denominator is 0, 1 times the numerator. So the shortcut, if you want to make a note, is just set the numerator equal to 0. And so we get 2 x-intercepts, negative 1 and 3. All right, so I'm going to dot those in. Okay, then step 5. Step 5 is the one we haven't talked about at all. Step 5 is how do you determine if it's going to cross that non-vertical asymptote? Now, like I said earlier, the vertical asymptotes are like brick walls. Never cross, not once, not at all. But the horizontal or the oblique can be crossed as a one-time deal. If this thing crosses up over it, you'll have to come back and stay above it. You can't cross twice. But to decide if it's going to cross that non-vertical, step 5 says, determine whether the graph will intersect this non-vertical asymptote by solving f of x equals b or f of x equals mx plus b, where b, or mx plus b, is the y value of the non-vertical asymptote. So in other words, if you want to make a better note, number 5 is take the answer to step 2. Take the answer to step 2, whatever you found for that non-vertical asymptote, whether it was horizontal or oblique, whatever you got for that equation, and then plug into y in the original equation. All right, so, I mean, sometimes it's hard to remember what that was, you know, because it was back a few steps ago. But what did we find was the equation of our non-vertical asymptote? Y equals what? 1. It's this line right here. That was y equals 1. That's what we found in step 2, the equation of the non-vertical. We take that, whatever y equals, and the reason the direction says it might be an mx plus b thing is if this was an oblique, a slanted line, it's more than just y equals a constant. It's got, you know, an x and a constant both, so an mx plus b. Whatever you found from step 2, you plug that in for the y back in the original problem and see if you get a solution. If it gives you a solution, that means yes, it crosses at that point. If it gives you a no solution, that means it does not cross. So we're taking y equals 1, plugging it in for the original equation's y value, and we're going to try to solve this. Now this is a little harder solved than what we just did on the x-intercept, because now it's equal to 1 and it won't wipe out that denominator. So we have to do a little more work. Now we'll cross multiply 1 times x squared plus 5, 1 times x plus 1, x minus 3. And then we're going to try to solve that. Okay, again, cross multiplying. There's just times 1, so it is what it is. And then this times 1 itself. Then to solve this, I'll need to FOIL the right side. So x squared, 5x, that's x squared minus 2x minus 3. I think we're going to get an answer. The x squareds cancel out. It becomes a linear equation. So we add 3 to both sides. Divide out by -2. You know, just do your algebra there. I get x is -4. So that means I have a real-time point at y equals 1, like if you were making a t-table, when y equals 1, x is negative 4. So 1, 2, 3, 4, up 1, it does cross that line at that point. All right, so that's step 5. Step 5 is kind of tricky. You take what you found in step 2, plug it in for the y value, equation solve, probably by cross multiplying, see if you get an answer. So a lot of times you don't, so that's why I was kind of surprised, like we got an answer. So if you do get an answer, that means that is your solution. That's the point at x is negative 4, we cross that non-vertical asymptote. All right, so here's what I really know. After you do all these steps, step 6 is point plot and try to figure out where this thing goes, but I kind of already know if you think about it. I know it dips here. If it's going to cross here, it can't also cross over here. It only gets to cross one time. So it has to stay underneath that. I'm not sure, how far it goes out before it gets very close, but I kind of know it looks something like that. Over here, I know it's going to cross, and maybe it just goes up a little ways, probably not a lot. We could plug in negative 5 and see, or negative 6, but it goes up a little ways, but then I know it has to come back and follow along that asymptote to infinity. So it may have a little jump there, but then it'll come back down. It can't cross back over, so it's stuck above it like that. All right, we'll bring this on. All right, so look at that. Let me know.